Hello explorers and welcome to another video. And today I'm gonna talk about all the things you can do with Git with a remote repository. And this repository could be either on someone else's computer, it could be a repository locally on your computer, but a different repository than that you are using, and it could be GitHub and other services that uses Git underneath. So the good thing to really take into account here that this repository that you will push changes to or fetch changes from is not a repository that needs to be a central one. It's just another repository. So you have one repository locally that you do your changes to, and you can push them to another repository, any other repository, and fetch from any other repository. So there's no central point in this system, which is very powerful actually. So one thing that I usually do when I record these videos is that I actually use GitHub and I add things to GitHub. So let's go over to GitHub and start this episode by creating a repository, because now I will talk about how to push things, and I will push them to GitHub so you can see how it works here. So up here we have a plus sign, and we can actually create a new repository. We can import one. You have gists and organization, and gist is just a quick edit of something, so you can share it with your colleagues when you are editing in just one file. But the repository, this is a full Git repository, so we will create one of those, and let's call this Git sample as we had before. This is just a simple example showing of the features of Git. And this could be private or public, and we could initialize this with the readme, so we will get a readme file describing this project, and usually they just put the repository name as some header and the description in this readme, but it could be a useful feature, so you have that file and can continue working with that file. Add git ignore. This is if you are using a specific tooling chain, or if you are using a specific language. There could be some files that are created, for instance in C you create object files that you don't want to share with other people, so you only actually commit your working files. And there's a lot of different things here. Let's say that we work with Java, see if we can have any. Yep, so here we have a Java ignore file, so it will create one of those for us. It's just a template. And then we have a license file here. There's a lot of different licenses. I'm not an expert in licenses. I usually use the MIT license, MIT license, because it's very permissive. You can use it pretty much anywhere, I think. But there's a lot of different opinions about licenses, and if you like another license, then use that. It doesn't really matter to me. I know that some of them are very restrictive of what you can do with them. Some of them you can't use in a company because you need to share all your code around them and so on. So some of them are more restrictive, some of them are very open, and it's up to you to choose a license that you like. So if we create this repository here, we will have a new repository on GitHub. Here we have our readme file, as I said. This title is a Git example, and then we just get this information here. We get this license file with the MIT license. So here, if you use this license file that Git gives you, you can actually read up what this gives you. So it's for commercial use. You can modify, you can distribute. It's you can use it in private if you like, and you're not liable for anything. You don't give any warranty for anything, and you need to keep a license and copyright notice in this file. So in this file you see that I have copyright Daniel, and that's pretty much it, and you need to keep that copyright if you like to use my file. It's pretty much that. So it's a very simple license that give the people using your code very much freedom. And then we have this git ignore, and these are all the files that you will not be prompted to commit. So no class files will be committed, no log files will be committed, no BlueJ, I have never seen this, but those will not be committed. And then we have some mobile tools that will not be committed, no jars, vars, ears, zips, tar files or rar files. And also these are very common virtual machine crash logs, and those will not be committed as well. So if you have this kind of file, you tell Git which file it should ignore when it asks you for if you want to add something or stash something in your Git repository. And I have to actually make a little bit of a correction to my earlier videos. I said that there were different between add and stash, and it's just a history reason. There is no real difference between them. They just were added at different times, and I like stash more than add, but you can use both for the same task, so there's no difference between them. So now we have a Git repository here, and here we have a green button that will show you a link for this Git repository if you like to either clone this Git repository or connect it with your local repository, and we will do that. So I will copy this one. So now we go back to our code editor here. We have our Git repository that we looked at earlier. We have a change in this hello file. So let's we can actually add this change. Hello Java changes to hello, and then we have not connected this yet. So if we do git push, it doesn't know where to push it because we don't have any Git repository added yet. And then it tells us to add something to another repository, you need to actually create a remote, and you can do that by remote add. So if we look at remote-v, we'll get all the information of all the remote Git repositories that we know of, and we can have a lot of them with different names. And I usually, when I create a remote, I add an origin remote if it's the repository that I usually push to. And I use the naming convention of upstream if I have one Git repository that I usually work with, and that is a fork of a different Git repository that is the actual origin of the work. So if I work on GitHub and then fork Git repositories, I have my own copy that I make my pull requests in, then the first real repository that other people had worked on is my upstream, and my own Git repository is my origin. So let's add this URL here that I copied earlier and add that origin. If we look at this V now, you see that I have a origin for fetching, which is one address, and origin for pushing, which is the same address. I don't really know why you would want them to be directed in different directions. You can do that, but I don't really see the reason why, because it's kind of hard to keep track of if you fetch from something and that's one location and then push to another location. But it's something you can do. And if we now do a git push, we will probably get this error, which tells us that we need to actually set the upstream of our push. We can't just push this master branch upstream. We need to tell it where the upstream is. So we push this and set upstream to origin master. So that's the master of the upstream repository. And now we get another one that says that you can't push this because you have changes upstreams that you need to actually merge with your local copy before you can push. And this is just so you don't get any errors or merge conflicts that are hard to handle. So you usually push something upstream when you have actually either merged or rebased your local changes. So that's an easier way for other people to handle this. If you push something upstream, the upstream doesn't know what to do with it, but you as an operator can pull something down and then see what changes you need to do in order to merge these two kind of files together. So we'll do that as well. We start with a git fetch, and this is just to fetch everything upstream, so we have everything local on our computer. And we can also say fetch origin. That will tell it to fetch the actual origin point. If we have multiple of them, so we can fetch upstream and origin, so we get both of the changes. And then we have two different commands. We have either Git Rebase, and this command will take the changes that you have on your origin or the other repository that you have fetched, and it will take all the commits in that commit log and push your commits on that commit log. So it will figure out where your commits are in the commit log and actually try to reapply your commits upon the actual commits in the log on the remote side. And this makes that you have a long chain of commits. So your commits will actually follow up on the remote commits in a good fashion. So you don't get any merges. Because when you do a merge, you actually look at which changes are done and create a new commit into the Git repository with all your changes. So that will actually look very different in the Git repository history, and your branching changes will be still a part of your branch and not a part of the main repository line or the repository log. So you will move your branch in instead of merging your branch in. So you will keep your branch outside and just make one commit in with all your changes. And people prefer different ways to do this. When I work with a branch that is not master, so if I have a branch that is actually a different branch and I do some change in that, I will always rebase in master in order to not get a lot of bubbles into the master branch. So instead of pushing things from the master branch into my branch all the time, I will just move the master branch's changes further back in the chain. So I will rebase when I work with my branches. But that's up to you how you want to handle that situation. So if we do a rebase on origin, it will need a single revision. So that's a bit strange, because I thought that we actually had a revision here. Initial commit. Let's see here. Git status, git remote. We have my new branch. We are actually on a branch here, so we can actually try this little thing that I talked about, that we will merge our branch in. So let's check out master. We will merge my new branch. New branch. So now I think we have all the changes of my new branch into my Git repository. Now we try to push and set upstream origin master. That should work better. Yes, and now we can Git Rebase master. Current master is up to date, so it's now up to date with itself, which is not helpful. Let's rebase it with origin master instead. So when you are talking about a specific other repository, you say the name of that repository first, and then a slash, and then the actual branch that you want to rebase. So we rebase with the original master, and we see here that we first get everything from the remote repository. We rewind head and replay our work on top of it. And here we say that it will apply first commit of the go source, hacker, the rest of the files, committed hello changes, and changes to hello. And we also see here that we have now our git ignore, our readme, and our license as files in our Git repository. So now we have incorporated all the changes that we did online with our local repository and added our own commits upon the remote repository changes. So now we can do a Git push, and we still need to set upstream. And this is something you don't do every time. It's just when you're setting up the Git repository, you need to set the upstream. Otherwise, it doesn't know where you want to push every time when you push something. So now we have set the upstream for pushing. And if I do some more changes here, we say we remove this. Here we have a change. We add this change again. And commit, removed a line, and then we push. We don't need to say anything else. It will just push it upstreams up to our other repository on GitHub. So if we now go over to GitHub, we'll see that our file changes are here. We have our hello Java, where we have removed this last line. So that was git add a remote, git push, git clone, git fetch, and merge, and also rebase. So we have done all those different commands. There's one more command we can do. So let's go in here. There's actually two more that I want to talk about. Added some more description. So we add some more description and added more. We will commit those changes. So you can work on GitHub with your files as well. So now I added something to my README, and on our local we can now do a fetch and then merge or rebase if we like to. But this is something you do so often that they actually have added a command called Git Pull. And Git Pull, as it is configured at start, is that it does a fetch and a merge directly for you. So it will fetch everything from your remote repository and merge them in. You can actually do a Git Pull Rebase that will fetch it and rebase it. You can also reconfigure your Git so it always rebases instead. So if we could do a Git pull, we see that it fetches the readme changes. There were 2 insertions, so 2 lines added, and that is quickly merged into my local repository. Yeah, I did some more setup here, so I wanted to show you one more thing. And what I actually did was went out and removed the Git example directory. So if we do a dir here, it's totally empty. If I do a git status, it will tell us that we don't have any Git repository. And the thing I wanted to show you is if you have a remote repository like this Git example on GitHub, and you clone that address and go here and then actually write the command clone instead, give it a URL and then where you want to add it. If you don't say anything, it will use the name of the Git repository as the directory name. But as I'm standing in the directory name, I actually want to put all the files in the current directory, so I add a dot here. So if I clone this, it will go out, fetch all the files and set up my local Git repository. And the good thing here is when I have cloned something, I'm up to date, can start working, and everything is actually just there for me. So if I go here and add a line again, hi, fine folks, how do you spell that, folks? Hello, fine people. And add and commit it again and push. You see that I can work with this Git repository without doing any extra setup because I've cloned the repository and therefore everything is already set up for me. So what we have gone through today is creating a remote repository, talked about that remote repository are not a specific server or anything like that. It's just another repository. So it could be your friend's repository at their local computer or a colleague's computer in the other desk over. And we have talked about how to set up a remote link, a remote name for other computers. And we have talked about how to push changes to them. We have talked about how to fetch changes from them and how to merge and rebase different things when it comes to after we fetch and we want to actually integrate the changes from the remote repositories. And we have also talked about what a pull is and how you work with pulls. And lastly, we cloned a repository from GitHub and started working, and everything was set up for us. I hope that you found this episode interesting. I hope that you know a lot more about Git. Things that you can run into when you are rebasing and merging is that you can get conflicts, and conflict resolution can be really hard. But usually it's just figuring out which changes should be kept and not, and adding them. If you have any questions, please leave them down in the comment section below. And if you want to see anything more of Git, then please tell me, so I will probably do one more video if you like. And if you haven't subscribed yet, do that. Like this video, share it with your friends, and I really hope to see you in the next video.